Hey, Thomas.
Hello, everyone. Yeah, we have a couple of questions. Great lesson, Derek. It was really fun and lots of information to unpack.
Thank you. Any specific questions you want? I feel we probably have time for maybe one or two questions. We'll probably take the rest of the questions to our Discord server and answer them in the comments. But any specific one that you think would benefit from like this live discussion?
Yeah, of course. Yeah, there are a couple of questions that are pretty interesting. Yeah, some people ask about perplexity and what's your thoughts about that, and can you elaborate a little bit more on advantages and disadvantages of perplexity?
Yeah.
Um,
Yeah, maybe we
what?
can. So we can start with that. I think so. Perplexity is actually like has like is a function of our loss, right? So, and loss is something like we keep monitoring throughout the training of any language model, and it's good to have like this chart where your loss keeps going down. And if both like the training loss and the evaluation loss keeps going down, it means like you are probably on the right track. Now, the loss depends a lot on what you have in your validation set. If you have like a rather small validation set, then this might not be very meaningful. If you have a pretty big and diverse evaluation set, then this may be like way more meaningful. I think it's also important, like what are you fine tuning or training on? If this is like a pre-training task and you're just predicting like the next word in a corpus of text, then this kind of speaks to the like the general abilities or memorization of or well, actually not memorization. If you're evaluating on a validation set, it speaks to like how good your model is in predicting the next word. But if you're now instruction tuning or then it already like kind of like reflects on how good it is at following instructions. I would say it's very helpful metric. It's easy to calculate it throughout training, and you should monitor it. But it's not sufficient because you might have a model checkpoint that gets lower validation loss, but it might have overfitted to some subsets of the tokens in your validation set, and it might actually make it worse on the metric that really is really important. So I think the answer is like monitor it, but also check out other metrics.
Yeah, nice answer. I gave a way more shorter version of that. It went in great detail. I think another question that is important to cover here is it's talking about like should all be training based on prompt and completion. And if your task is if your final task is classification from text, and maybe should we be training with completion or not?
Can you say again, training with competition or completion?
Like autoregressive or causal ML, like generating
Yeah,
next token prediction. If your
yeah,
final task is gonna be like
yeah.
sentiment analysis or
Yeah,
classification.
I think that's a great question, and I would say, um, so these auto-regressive language models that we're focusing on in this course, like their power comes in their like general purpose capabilities, right? So we evaluate these models, for example, on classification tasks, but we also evaluate them on the summarization. We evaluate them on code generation. So we try to comprehensively evaluate like what type of knowledge they have and how good they are at different tasks. But if your application is sentiment classification, then I don't think like in real life, like I would use GPT-4 for that. I would probably train a small BERT model and just focus it on the sentiment classification. But if it's on the other hand, like if this is part of like an agent and I don't know in advance what it's gonna need to do, and at some point it may like require to classify something, like it should have this capability. So I think yeah, if you are trying to develop a classification model, and you have a big data set and you can train on this data set, maybe take one of the encoder models. But if you want to build like this general purpose machine, then autoregressive models seem to be winning this battle.
And a final thought: a lot of people are asking like hands-on, ex- yeah, showcasing how to run these benchmarks because it can be very like overwhelming.
Yeah,
And I will point people maybe to watch like a use lesson, and we went
yeah,
back and forth trying to run human eval. and the Helm benchmark. And yeah, they require a lot of time and setup, and they are not that easy to run.
Yeah, that's a great point. And we encourage again to go back to the video from last week and check out like the code prepared by Ayush and yourself, Thomas, for evaluation. And if we have demand, I think we can do like a follow-up tutorial on running some of these evaluations heads on, so we can do a lab session on that.